Hello, welcome back. This is Calculus by Dr. Oz. So today we're going to find the area of a region bounded by the graphs of three equations. One is f of y to be equal to y divided by radical 16 minus y squared. The other one is g of y equals 0. And other one is the horizontal line y equals 3. So one thing that could have taken your attention here is that all of the functions are given in terms of y, and you could just ask yourself why. Because we can represent functions in the form of y equals f of x. This is what we have been doing so far, but also you can represent functions as like x equals f of y or x equals g of y. Speaking of that, x equals g of y equals 0 is just x equals 0, which refers to the y-axis. So what we're going to do here is first we're going to plot the region, see what it looks like, and since the functions are given in terms of y, we're going to use an alternate version of the area formula where you don't have any dx anymore, but we're going to have dy. So, and here is how the region looks like. So this is the area that's surrounded by three graphs. As you see, y-axis, the horizontal line, and the blue curve over there. So as I told you, we're going to use an alternate formulation for the area to come up with the area of the green region. So I'm going to plot it again in the video. Please have your TI-84 ready before we get started. All right. So we have f of y equals y over radical 16 minus y squared. We have g of y equals 0 and y equals 3. So you have three tasks to do right now. Please have your TI-84s and make sure that you first graph this function. This is a function of y, so be careful on that. And you have g of y equals 0, which is equivalent to x equals 0, which is also equivalent to y-axis. So essentially, g of y equals 0 is equal to is just y-axis. Okay, x equals 0 in other words. Okay. So, and this one is a horizontal line, right? Horizontal line, y equals 3. So go ahead and please graph all three curves here. One of them is, in fact, y-axis, and the other one is the y equals 3 horizontal line, right? So your task is just to graph this function now. And you can pause the video anytime. But you should be able to see something like this. Okay, after you graph, the blue one is y equals, it's right here, y equals 16 minus y squared and square root. And then you have the y equals 3 horizontal line, which is the purple. And there's the y-axis here. Let me just also make it bold here. So here we go. So and the region enclosed by these three curves would be exactly the green region. And the question is asking to find the area of this region here, okay? So this is slightly different from the problems where we have a function of x is provided to you, and then you're trying to find the area between the curve and one of the axes, right? In fact, it used to be like x-axis earlier in Calc 1. So if, for example, the question was asking like, what is the area in between this region? We know how to answer this question. But what if the area between this curve, this blue curve, and the y-axis, so this is your y-axis, right? Let's say from 0 to whatever this point is, we're going to figure that out, okay? We're going to figure that out. Which is, in fact, we know that point, y equals 3. We don't need to figure that out, I'm sorry. This is y equals 3 vertical line, so y equals 3, okay? So how do we consider the same area problem, but this time you are looking at the area between a function written in terms of y and the y-axis. Okay, let's consider that for the time being. And we're going to look at this problem the same way that we have the top curve, the bottom curve, but when I say top, what I mean by that, the positive x-axis side of the graph, and the negative side of that is the bottom. So in that regard, so blue guy here is going to be the top function, top curve, if you like, and the red is going to be the bottom.
because eventually we're going to put everything in the integral, and I'll put the y version of those functions exactly the same, and I'm going to look at the difference. So what I'm trying to say is that we have the integral, the top function here, so top minus the bottom, but this time this integral is going to depend on y, okay? And within this region, y's are in between, as you see, y's are in between 0 and 3. Okay? Within that region, y's are in between 0 and 3. So for that reason, I'm going to put a 0 here, 3 here. Okay? So now I'm going to put the y version of the functions, which is in fact what are provided in the question. So this is the area, right? So this is equal to integral from 0 to 3. The top function is the blue curve in this setup, right? The positive x-axis side is the top, okay? So y divided by 16 minus y squared. And the bottom function is y-axis, but as I said, y-axis is another way of representing that is just saying x equals 0. In other words, it's just, so this is also your x equals f of y, a function of y, right? So, and x equals that, minus x equals 0, okay? So this is exactly what I'm going to do the integration for, okay? So, and then this is on y, okay? So now this boils down to the integral of y over, let's say, 16 minus y squared dy. And this is a good u substitution problem. So I'm going to go ahead and then handle this u substitution right here. Okay. So y over 16 minus y squared, right? So here we go. Let me just clean this part a little bit so you can actually see better. There we go. Y. Okay, there we go. So now you see better, I think. All right, so we have dy as well. I'm going to call u to be the bottom without the radical. So du is going to be negative 2y dy. Okay. So this integral turns out to be negative 1/2, negative 1/2, negative 1/2 du over radical u. Okay. You can just rewrite that as like u to the negative 1/2 and integrate by parts. So it's integrate it. Integrated, so u to the 1/2 divided by 1/2. So those 1/2s cancel out, so this becomes negative radical u plus c. Okay? Please have it as a separate problem over there. So, and you can put the u back over there to get, let's see, to get here, I'm going to continue from here, negative 16 minus y squared from 0 to 3. Okay? And negative 16 minus 9 is what I have when I plug in the upper limit, minus negative root 16. Okay? This turns out to be negative root 7 plus root 16. So in other words, 4 minus radical 7. Okay, go ahead and use your calculator and get a number of decimal places. Okay, so this is approximately equal to 1.354. Okay, you can go back and, sorry, this was the previous problem. Conclude that this area here is equal to 1.354. Okay. Again, this is a completely different setup that we are not looking at the area between the curve and the x-axis, but we are looking at the area between the curve and the y-axis. So for that reason, the function is provided to us in terms of y. If not, you have to convert that by yourself. You have to write it as like x equals f of y once the description of the function is provided to you. And the integral is going to depend on y, not x anymore. All right. I think that's it. I'm going to finish the video right here. If you have any questions or comments, please send those to my way. I'll see you in another video. Bye.